All right. Hey, everybody. How's it going? So, last year during our Modern Cloud Operations webinar, we spoke about this generational shift where organizations are moving from static to dynamic infrastructure. Today, we're going to build on top of those concepts. But just in case you want to catch up, make sure to check out our Tevora Cloud YouTube channel or our website. Any of our marketing material that comes out, we'll reference, the Modern Cloud Operations webinar and the other series that we've done over the last couple of years. So for today, I felt the best way to start this prevention of vendor lock-in was to recommend 8 vendors that will help you prevent vendor lock-in. I'm just kidding. All right, let's get this webinar started. So in this new dynamic world, security, operations, networking, and developers are all facing different challenges based on their own business requirements. But when it gets boiled down, there are a couple of core similarities. That gives us an area of commonality in which to start. We know that code collaboration is a huge driving force for adoption. And with increased complexity in our own environments, it's difficult for a single person to reason about the environment alone. Collaboration provides checks and balances. It keeps teams on the same page, and version-controlled infrastructure drastically helps manage security and compliance requirements. So the business has established the codification of our infrastructure as a core requirement. They've also stipulated that workloads should be immutable. So let's break that down further. When we say codify, we mean to capture that routine, process, or configuration. And when we build our workload, it should be immutable. And that means that we can delete and restack our environments without fear of data loss. And the last core requirement before we dig into it is that we use a solution that allows us to have declarative code. This means that we specify the desired state, and it is generally human readable as opposed to being imperative. Declarative code is really going to future-proof you. At Tevora, we spent a significant amount of time training our other towers around this concept, just for this specific example. So a couple of years ago, when we were doing security audits on the PCI side, they stipulate that you use an industry standard sampling methodology. So you're going into a client, say they have like 100 systems, some of these sampling methodologies, they want you to have common sets of systems and that you sample 10% of them. All right, so we're going to scope through this and, there's 2 sets of 10 that we're going to be sampling against. So 20 systems, not too bad. But what does it look like, when systems start getting into the thousands or they start, load balancing, or you have containers that are spinning up to meet the demand that are then spinning back down. And this whole concept around, being able to validate things as code has been huge. And that's why we really try to stick with these declarative solutions. So that way you don't have to be a programmer to really understand what you're looking at. So with that said, let's talk about some risks to be aware of. So over the years, we have found certain core areas that become a risk and can slow down an organization's ability to push for that evolutionary architecture that is commonly spoke about. First one has to do with roles and responsibilities. So, on the infrastructure as a service side, your AWS, your Azure, your Google Clouds, these are really the gold standard. On AWS, if you log into the web console and if you click on the artifacts link, you're going to find a huge repository of various compliance requirements, roles and responsibilities, and what those look like, in AWS's shared responsibility model. And that shared responsibility model gets broken down into of the cloud and in the cloud. I believe it is they're responsible for of the cloud. So their systems, the physical infrastructure, the hypervisor itself. And then in the cloud is the customer's responsibility. Right. So AWS turns a lot of these security features on by default, but there's things that their clients are expected to do, like harden their security groups to just permit traffic that is necessary for a workload. With a PCI workload, if you're using virtual machines, EC2s are supposed to have host intrusion detection systems and those type of things. Now, these roles and responsibilities also kind of come out to a lot of these like SaaS providers. Many times, if you ask for a role and responsibility matrix, if they're going to provide it to you, they'll provide maybe a SOC 2 audit, Maybe there won't be a roles and responsibilities matrix. And a lot of the times they just get into things like managing your access and they handle the rest. I can rant more about this, but really, before you pick any type of technology component, make sure that those roles and responsibilities are aligned with the business capabilities. So during this initial phase, we find organizations, they tend to virtualize technology, or we'll commonly hear it as lift and shift. So, they're familiar with these things. Let's just take these things, virtualize and stick it in the cloud. The issue with this is you start to really walk a fine line between the native efficiencies you just gained while moving to the cloud, which are defined in those roles and responsibilities I just ranted about. And then you start increasing the complexity because you are no longer leveraging these native capabilities. And it starts really expanding really quick. For example, if you virtualize a firewall, AWS, when it comes to PCI security groups, they provide the stateful inspection. So as long as you harden those security groups to what is needed for your actual workload itself, things are great. If you layer in a firewall, it starts augmenting some of those capabilities. And you start getting into, okay, well, now just instead of looking at the security groups, the inbound and outbound rules that exist, now we have to go into the running config, make sure that this virtualized hardware is okay, make sure that the traffic in the security groups is least, is restricted just for it to actually function. You start expanding that scope, which expands, your compliance efforts themselves. Networking. So over the last couple of years, we've seen how organizations change how they actually operate. So they've gone from a single account with many VPCs to segmenting these environments at the account level. This account level segmentation is generally referred to as a landing zone itself, and AWS stands by and just looks the way the greatest form of segmentation in the cloud is at the actual account level itself. So now our clients have grown from 1 account to 2,000 accounts in a year. Easy fix. We just increased the effort by 200x, and we're all going to be good. Obviously, there's scale issues here, which we touched on a little bit ago, talking about, how do we sample, the necessity to be using declarative code to be able to reason about the environments and so on. So let's dig into network challengings a little bit more. So far on the networking side, we've had a couple of core challenges. Now that you are scaling exponentially, how do you monitor for compliance? Have you adapted your model to include service discovery and routing? For example, in PCI, an accurate inventory in the cloud has been a hot topic, especially with organizations that treat their systems as being disposable and cycle them on a weekly or daily basis. We know that in multi-cloud environments, we want to consume a service. Maybe we want to use a VM in an Azure for compute and S3 for storage within AWS. Setting up the available private connections between the environments, it's going to get costly. So you start thinking about this multi-cloud. Right now it's kind of like this trendy word. Why would anybody do this? So this is where we start to look into services that provide service mesh capabilities. This generally means leveraging technology. It generally means leveraging a common foundation and technology that allows for service-to-service connection, authorization, and encryption using mutual TLS connections. And this really starts to solve the questions of ensuring that there is parity between your environments. The next thing we're really going to start talking about that we run into has to do with secret managements. No, not LastPass and 1Password. We're talking about Azure Vault, AWS KMS. They're great. It really solved this, issue we saw with hard coding sensitive variables and configs that are now stored in your code repos. And so now everybody just uses, sets their stuff as in parameter store and calls those variables when it's actually needed, right? So although the technology has been a blessing, there are a couple of core risks with these native solutions. For example, when you want to start to explore how you get secrets and keys outside of AWS because the organization has prioritized using Azure this year, how are you going to do this? This is a big topic when organizations really want to dive into that multi-cloud to diversify their risk and spread it between multiple cloud service providers. Or maybe you have customers that are closer to certain edges. So in the traditional world, an application makes a request. It provides credentials, and hopefully just the requested information is presented. In the world of cloud, you want to be able to authenticate the identity against some trusted source before granting access to those systems. So you want to perform this in a dynamic way that can provision against any identity model that you really care about. So flexible identity model is core. Next thing is encryption. So since all apps are coming from your newly selected secret manager, this enables a couple of really cool things. First, it allows you to now enforce policies to encrypt all things in that flow. It also allows for the centralization of secrets and credential management, as well as encryption of all data in rest and in flight. This, coupled with these mesh networking type technologies, starts to address many of our security and compliance challenges that we've been running into as organizations really start scaling. Then, as things get more and more advanced, things like storage, compute, and networking start to shift from these static things such as S3 and RDS, and they start turning into pools of infrastructure that are ready for consumption. So now that we have figured out encryption, identity, and networking, great. So now we can go to our developers who have some Java app, some C# apps, some container-based apps. So then we get to pick a solution that will handle scheduling for us across our newly deployed architecture. You want to integrate with this all the way that it was built. This is easy now since we spend the time implementing a secret manager that is flexible to handling the identity challenges. And we have a network design that allows us to pick where we want to deploy our apps based on security, privacy, region, or compliance requirements. And that flexibility that we put in at the foundation really starts to make all of this effort come together. So we are now aware of some common considerations and issues, and now we have a plan. We're going to codify all these things and make sure that we pick the right solution and fit the right solution to fit that right Lego piece. So what else should we be thinking about? Well, so we live in a world where tooling is no longer an optional thing, and there needs to be a strategy to enforce consistency across these complex environments. And time again, that strategy to enforce consistency across the environments is turning things into code. And again, I'm going to hammer this in a little bit. It's capturing that routine process or configuration. Allows for a repeatable and a scalable environment. With this approach, there's this intrinsic layer of isolation that allows us to define our problem within our respected domain very specifically. The world does not need to be solved, just our tiny corner of it. I joke about this with our clients all the time. Treat workloads like Legos, picking the right yellow Lego with 8 dots to fit the particular workload needs. And then once that code has been captured and teams are all speaking the same language in a common format, we can then build these CI/CD pipelines to automatically build a workflow that works for collaboration, provides sufficient segmentation, and allows us to gain assurance not only from a security perspective, but also from a resiliency perspective. So we have made these architecture decisions, which allow our organizations to scale securely and meet the upcoming security and compliance requirements that we have been discussing internally. So what are some of the things that you should be doing and can be doing with these type of core foundation in place? One of the advantages is linting. So once code is captured, linting allows an organization to enforce their own opinions on that code. This is commonly done in the form of static analysis and alerting. In this, organizations can go as little or as complex as they feel necessary. That analysis of the code leads to linting, which allows organizations to enforce consistency as the workload matures over time. This, again, we found to be a key component for adoption. So now that all the code is captured, my favorite thing to be able to do is to be able to threat model the output. This allows us to take these abstract concepts like infrastructure and networking and input them into something that allows us to interrogate our design. For example, Terraform allows you to output into a dot or a dot file or dot file. And you could take this output source, you could take this open source format and leverage academic tools to 3D visualize the world that you just architected. So gone are the days of manually configuring your infrastructure, making a diagram that maybe looks similar to how it is. We can actually get a live diagram that shows us exactly what that infrastructure is and start interrogating the design. We could also start to enable and implement things like automated reasoning. This is a really exciting field where services are mapped to, quote, math language, but it allows you to interrogate the configs with questions like, is my database that lives in my private subnet able to access the internet? These tools leverage math proofs to answer your question, generally without sending a single packet through the environment. And what we're seeing here is people are going to start using this to really start to prove compliance, potentially without even, logging in and hitting a system, which is pretty exciting. And I'm pretty amped to see how that's actually going to work. Here's some examples of the threat modeling type outputs that we generally do. So we are seeing this cultural movement where mature teams are shifting their roles from putting out fires to causing fires in order to understand their environment's weaknesses. Netflix used to call this chaos engineering, but similar to things like red teaming, you kind of see like the phrasing shift a little bit. But chaos engineering or resilience testing is generally what we see this type of exercise fall under. But these teams can be confident in their workload's ability because the workload has been designed to be scalable and repeatable, and there are no nuances from one environment to another. And that consistency fosters adoption. And this allows us to help organizations set up tools like TensorFlow for security operations. Gone are the days of performing the usual dog, not hot dog function that we're all used to joking about. It can be used to analyze logs and metrics and really pick out that needle in the haystack in these huge environments. And then when it comes to things like distributed tracing, technologies such as OpenCensus allows teams to understand the flow of traffic from the internet to a microservice. This is generally used to pick out things like a bad deployment, but we've been leveraging it also to understand, hey, is there a malicious individual also in the environment? So thanks again, everybody, for hanging out and coming to our webinar. Any questions, feel free to reach out. My contact details are right here, and looking forward to chatting with you on the next one.